All right, guys, now we're going to take some notes about how to identify a function. All right, so a function is a relation. And you can kind of think about like a relation as somebody you're related to or in a relationship with. Your relative, some people say your relation, the people you're related to. So it's just the way the numbers are in a relationship with each other. Each input produces exactly one output. And this again is the example with the Coke machine that we talked about, where each button I push, if I push Coke, I should get a Coke and only a Coke. If I push Coke, I should not get a water or a Diet Coke. Okay, so it should only have one output and I should know what that output's going to be. All right, inputs are independent values. Okay, outputs are dependent because they depend on the input. Okay, and then here in the circle it says input values are this is called our domain, and our output values are called our range. Okay, so just some vocabulary words you kind of need to understand. Independent means it doesn't rely on anything. So the Coke button on the machine is independent because it's just labeled Coke. When I push it though, what comes out, whatever comes out of my vending machine depends on what button I push. So when I push a Sprite button, which is independent, depending what comes out of that machine is based on the button I push. So if I push the Sprite button, a Sprite comes out. Okay, domain and range are just vocabulary. So input values or the buttons on my machine would be the domain, and then what comes out or is my output is my range. Okay, so there's a couple different ways we're going to be looking at data. We're going to be looking at ordered pairs. Okay, and this says here if an x value repeats with a different y value, the relation is not a function. And when we're talking about ordered pairs, this is what we use when we are going to graph. And remember, you learned how to graph on a coordinate plane, and you had your x value. Let me blow this up so I have a little bit of room. You have your x value, comma, y value, and parentheses. So that's called an ordered pair. So for example, in the ordered pair 3, 2, that tells me that I have to move on the x-axis over to 3. So I'd go over 1, 2, 3, and up 2, and I would put my point, I'd plot my point right there, okay? So ordered pairs are the x-y combination. So looking here, in example 1, my first ordered pair is 1, 2. My second pair is 2, 3, 3, 4, 4, 5, 7, 7. So it says if an x value repeats. So let's look at only our x values. Okay, that's the first number. So I love this because all I have to do is look at 1, 2, 3, 4, 7. Did any of those numbers repeat? 1, 2, 3, 4, 7. No. So that's like having 1, 2, 3, 4, 5 different buttons on my vending machine. So let's say 1 was Coke, 2 is Diet Coke, 3 is water, 4 is Sprite, and 7 is Coke Zero. So each one of those buttons is going to produce exactly what it's supposed to. Now let's look at the example below, example 2. I have 1, 2, 1, 4, 2, 3, 2, 6, and 7, 9. So this time, if I look at my x values, I have a 1, a 2, a 2, and a 7. So if 1 on my vending machine is a Coke, and I push that 1, this here is telling me that I could get a Coke or maybe a Sprite. because that one value has been assigned or given two different outputs. Okay, let's look at it over here. I have a 2. Let's say 2 is my Sprite button. So I push Sprite and maybe I get a Sprite. Let's say 3 is Sprite. Or I can push the Sprite button, but I get a water because 6 is water, okay? And again, I'm just using the Coke machine just because it's something we all know and we're familiar with, and it kind of, to me, makes sense to do it with something we already know. But what this is saying is that I have my X value, or my input, has different outputs, okay? So you can look in the example set 2, and I have repeating X values. I have 2 1s and I have 2 2s. So that's not a function, okay? A function only works when there's one output for each input, okay? Let's talk about domain and range. So another way, and again, we talked about domain as being the X value, or my input. So here, if we take example 1, okay, so we're looking at example 1 now, here, down here, okay? And so what we're looking at is only those X values. So just like here where I had 1, 2, 3, 4, 7, we now put those in together. And then where we had 2, 3, 4, 5, 7, I put those together down here. So now looking at that, I can look at my domains and I can see that none of my numbers repeat. So I know it's a function. So that's why we have that check mark. In my next one, example 2, we did the same thing. I took the 1, 1, 2, 2, 7 and put those together here. And then my Y values were 2, 4, 3, 6, 9. I put those together here. And if we notice, I have 2 up here. I have 2 number 1s and 2 number 2s. So I have repeating domains, or repeating inputs, so it can't be a function, okay? So all we're going to be doing is working with identifying sets like this of, are they a function or not? But we're also going to look at tables. This is one other way, and then we're going to look at some graphs as well. So in a table, when you have a table set up, you have your X values here in one column, and then your Y values here in another, okay? So again, let's look at our X values. I have 4, 7, 8, 12. Do any of those numbers repeat? No, it's a function. Now in my table 2, here's my X values. I have 3, 3, 5, 10. All right, let's take a look at something. Here in this first one, 3 is assigned to 6. So 3 is partnered with 6. But down here, they partnered 3 with 9. So if this was a vending machine and I pushed 3, I could get a 6 or I could get a 9. I don't know what I'm going to get. So when that happens, there's 2 outputs now for that input, and the rule says you can only have one output. And this is my output, or my Y's, okay? So if I push 3, I don't know what I'm going to get, and so that cannot be a function. Okay, think of a broken machine. You don't know what is going to come out, so it doesn't work. And again, that because table 2 has repeating X values, we had 2 number 3s in here, it's automatically not a function. Okay? One other thing, we're going to spend some more time talking about this. I'll introduce this to you now, though. This is called a vertical line test. And this is when we're looking at a picture and we're looking at a graph, and we ask ourselves, is there anywhere I can draw a vertical line through my picture? If I can do that and my red line only touches that black line in one place, then it's a function, okay? Because for every one input, and we're going to spend some time doing these, but for every one input, there's only one output. So each ordered pair on this graph only has one input and one output. Now, in this example here, do you notice that my red line touched the black here and here? So it touched that line, or that circle, in 2 places. That tells me it has 2 outputs for 1 input, so that would not be a function. Okay, this is another example here. Again, if I can draw a vertical line anywhere, okay, as long as it only touches, it's that each line is only touching in one place. So no matter where you draw your line, it should only touch that black line one time. If that's called the vertical line test, if it passes, it's a function. Okay, and again, like I said, we will spend some time just doing nothing but this. But this is an example of what a function is. So I hope this made sense. I know it's a little bit kind of like, what's it have to do with math? And that's what we're going to be getting into. It's because we're going to be looking at these ordered pairs and tables and graphs and determining that. In our next unit, we're actually going to be producing the lines that make these graphs and looking at tables and data and actually doing a little bit more with those and talking about slope. So get all these notes copied down and hold on to this page, and we will talk today at 2 o'clock. It's Thursday. So we do have a 2 o'clock meeting, and I would like you both to come. So Leon, I want you at that meeting as well, and we'll go over a little bit more information. All right, so I'll see you guys then. Thanks. Bye.